We will go over both 9E.1 and E2. So we'll do E1 now, finish the exercise, go to recess, come back and do E2. So I think they're both reasonably short, sort of 5 questions each kind of thing, and pretty well the same thing, just E2 takes it a little bit further. And so here we've got parametric equations, right, but they're trigonometric, okay? And so what this here is going to describe is something travelling in a circle, and there are variations of it, but this is a simple version, okay? Something travelling in a circle, and we've got all of these properties that we're going to apply in the question. So we've got a falcon travelling in a circle, in a thermal column, right? So that's a column of hot air that's rising in a circle, and the falcon's travelling around in that circle. Okay, the position of the falcon is given by this equation. That's its parametric equation. Distances are in meters, time is in seconds. Find the position of the falcon initially. So that means find P of 0. When time is 0, what's its position? And then find P of 3. So when we put 0 in here for T, we're going to have 15 times cos of 0. Alright, 15 times cos of 0. That's going to be 15 times 1. And then we're going to have sine of 0, which is 0. So its initial position is 15, 0. Its x value is 15, its y value is 0. And then P of 3 is going to be a little bit different. We're going to have 15 cos, I'll write this whole way out this time. 15 cos of pi on 6 times 3. 15 sine. Pi on 6 times 3. Now, pi on 6 times 3 is pi on 2, and cos of pi on 2 is 0, and sine of pi on 2 is 1. So we've got 15 times 1. So after 3 seconds, its position is 0, 15. So you can think it starts here, after 3 seconds, it ends up here. Alright. Part B, determine the speed of the falcon. Oh, you fellas have merged with us, eh? Okay, so determine the speed of the falcon. So we're going to be referring to our properties here. The last dot point, the speed is r times w. So we've got the basic equations there, r, w, t, and the speed is going to be 15 times pi on 6. Alright, so that's just 15 pi on 6. We can simplify that a tiny bit, can't we? Divide both by 3, and we get 5 pi on 2. Speed is 5 pi on 2. We need a unit for it, meters per second. Distances are in meters. Okay, so where did I get that from? It's the amplitude multiplied by the coefficient of the variable. Okay, so that's part B. Turn the page, part C. How long does it take the falcon to complete one lap? So you could look here and you could do a process of elimination, right? It took 3 seconds to travel a quarter, so it's going to take 12 seconds to travel a whole. You could think about it like that. That would be sufficient. But we've also got a formula again. That's going to be our third one. W, okay, this coefficient of T controls how quickly P revolves around the circle, and the time P takes is 2 pi of W. So we're going to have the time for one revolution is 2 pi divided by what's W? It's pi on 6. 2 pi on pi on 6, 12 seconds. Alright, so the falcon is flying in this circle in 12 seconds. Okay, part D. Find the velocity vector after 5 seconds. So if this is the position vector, the velocity vector is going to be the derivative of that. Okay, so let's state the velocity vector. Alright, so the derivative of the x is going to be, when we differentiate cos, it goes to negative sine. So we're going to have negative 15 pi on 6, sine pi on 16.
Isn't it 1 on there?
No, that's integrated.
Oh, okay.
And then the derivative of sine is positive cos, so we'll have 15 pi on 6. Sine pi on 6 cos, cos pi on 6t. So I might just list the differentiation rules very quickly so you can remember. If we have sine of f of x, the derivative is f dash of x cos of fx. And if we have cos of f of x, the derivative is negative f dash of x sine of f of x. Okay, so that's what I'm using there to get the velocity vector. And we're interested in the velocity when time is 5. T is 5 seconds. So when we substitute 5 in there, what we're going to have here, we're going to have minus 15 pi on 6, and we're going to have sine of 5 pi on 6. That's going to be the x component, the horizontal component, and then the y component is going to be 15 pi on 6, and we're going to have cos of 5 pi on 6. And then we're going to look at our unit circle, put them in our calculator. Sine of 5 pi on 6 is half. And cos of 5 pi on 6 is negative root 3 on 2. And so that's the velocity vector. Okay, so that's the horizontal component, that's the vertical component of the velocity vector in meters per second. Okay, so those are the things you're doing in this exercise, right? You start with some equations, and it says like find initial position, find how fast it's moving, how long does it take to do a lap, velocity vectors. Yeah, so we started with equations. Some of them might give you some initial constraints and get you to develop the equations, but you should see how it all connects together. So yeah, 15, that's 9E.1. Let's do that.